Okay, so the first question was about car manufacturer, certain part lasts 40,000 miles on average. I definitely recommend the picture as a starting point. So I'm gonna go ahead and just sketch that out real quick. This is not gonna be beautiful, but whatever. Middle and then 3 to the right, and 3 to the left. Okay. And go ahead and just walk me through the numbers from left to right, and then I'm going to get rid of this draw.
So put 40,000
in the center,
in the
right?
middle?
Right. And then as you go left, how big are our steps here? That's the important question. What is it about the question that tells you how big the steps are that you're taking as you go from the center?
So then I think going to the left, you're gonna add 3,500 to the 40,000.
Okay, so 3,500 is definitely the step, but it's just like a regular number line. Smaller numbers will be on the left and bigger numbers are going to be on the right. So we go adding 3,500 as we go to the right, and then subtracting 3,500 as we go to the left.
Okay, I got all of that, but I must have messed up somewhere when it came. Okay.
Good. That's a good first step. And this should give you the scaffolding that you need for the first statement, which is the 95% statement. So which boundaries am I drawing around the 95%?
So it's between 43,500 and 47,000. Is
No.
that the 95? No.
No, this is 95%.
33,000.
You have to go from the left to the right. That's what I meant.
2 steps to the left and 2 steps to the right.
To the right. Okay. Okay.
So then that is what I need to know. Now, how do I make that statement? I mean, an easier question is just going to be picking it out of a lineup, right? A harder question is you need to make the statement about what you're expecting here. So
is it between, what's that, 33,000 and 47,000? Oh, well, is they asking percentage or just numbers?
this is 95%. So
okay, so it's between 33,000 and 47,000 parts. Parts last longer than 45 miles?
no,
No.
95% of the car parts last between
33,000 and 47,000.
Yep.
Oh.
So, this would be an easier version where you just have to pick out what the range is, and the harder version is having to make the statement yourself.
Okay.
This is the template concept where you have percent of is between
Okay, so I had got confused when it came to that 95%. I was just thinking going towards the left. I didn't think like I had to do the left and the right. I mean towards the right. I had to do 2 steps to the left and 2 steps to the right. And that was all of that is a 95%.
Right. And that's called the empirical rule. And it might be 95%, it might be 68%, it might be 99.7%.
Okay. Because 68 is the 1 to the left, 1 to the right.
That's right.
95 is 2 and 99.7 is 3. Okay.
That's right. Okay, so that was the first part of the first question. Then the second part requires you to find a z-score because it's asking about what percentage of parts would last longer than 45,000 miles. So longer than 45,000 miles. So the reason we need a z-score here is because this is not on the grid in terms of the z-scores, the mileages that we have, right? So I'm going to try to redraw this curve kind of over the numbers that I have. So 45,000 would go here, which means longer than 45,000 is to the right here. It's not very much. That's an important part for step 3, but let's go through the process. So the first part is the z-score. Roderick, are you going to say something?
No, I'm good.
Okay. So how do I calculate the z-score?
So would that be
Value minus main.
40? Would it be? Oh, okay.
Value minus mean divided by standard deviation. And my recommendation
Would
is
it be 40,
fill in the
45 minus 40,000 divided by 35?
fill in the mean and the standard deviation first, because those are easier to spot. And then the last number is going to be the other number in the problem.
Is it 45?
Right. So 45,000 is going to go in the front because that's the value that we're trying to find the z-score for. So z equals 45,000 minus 40,000 divided by 3,500. Don't forget, if you're doing this all at once in your calculator, you would need parentheses there. You're going to get some crazy number. So that's what you should have gotten for the z-score, which is just the first step of the second part.
Okay, I got that.
Okay, so then how do we move forward with that z-score?
Do you make it a probability? Like you gotta look.
Using this table, so where are we going to go? What's our probability going to be?
I didn't see the chart.
You got your formula sheet, Roger?
Would it be 1.4?
Yep, we got to use 1.4 because there is no 1.42857,143. So we use the nearest one, which is 1.4, and that converts to
It's 0.0808.
what?
Is 0.9192?
I think you're already on to the next step, Emily. So,
Actually, I was looking at the negatives.
oh, all right. Well, be careful with that. Yep, because that is important, right? There's a 1.4 and a negative 1.4. Right, and I would convert this into a percent. So I'd say something like 92%. I'm gonna clear out this drawing. Well, actually, I think it's still kind of useful. So do we want the majority part or the minority part? Remember that anytime we have this,
Gotta subtract from 100.
that's right. Anytime we have this whole thing is 100%. And if we draw a line, we split it into two parts, the majority part and the minority part. What we find is the left side. And so given that we want the right side, there's two ways to think about it. Given that we want the right side, we need to subtract it from 100. Another way to think about it is, since you got 92% from your z-score, and this clearly is a small piece, that's not what we're interested in. We're interested in 100 minus 92%. Okay, so then I would say the answer is something like, we expect 8% of car parts to last longer than 45,000 miles. Or of these parts. Because because this is all the same part. And on average, they break down at 40,000 miles. But of course, some of them last longer, some of them don't last as long. We expect about 8% to make it more than 45,000. Okay. Any questions about this process? That's really two separate questions.
I was confused on the second one. I set the Z-score up right, 45 minus 40,000. But at first, what I did was I used the 47. I was confused because I watched the video. And at first I had added the percent. You know how you got 32, 13, 13.5, you got 2.5, and you got 0.15. So when I was thinking they was like 45 miles more than, that's how I got the 47. So then I had added up the 2.5 and the 0.5.
Right.
And the 13, and so that was I did that the first time, so that was wrong. It gave me 16%. So then when you had told me to do the Z-score, I did the Z-score at first. First I used 47, but then I was like, that wasn't the value. Then I used 45.
Right.
And so then I had got the Z-score, but then I didn't know how to get the percentage, so I was stuck right there. But then you just showed me how to do it.
So that just on Karen's point there about this drawing, this is a helpful drawing, but I would encourage you to just use the Z-score to move past the drawing, because the drawing is only good if we happen to get a Z-score of -3, -2, -1, 0, 1, 2, or 3. And so since there's a lot of other Z-scores out there, it's a limited use, but it's a good starting place to mentally conceptualize what's happening in this problem.
Okay.
Okay, let's talk about the second one. Average life expectancy, 76.2 years, standard deviation of 4.5 years. What percentage of people are expected to live less than 70? So again, I think a good starting point, it doesn't say anything about doing this, but I think drawing it is a nice way to just frame out what we're talking about. So you can see the picture. Remember, this is a distribution. We got 76.2 in the middle, and then we're going up and down from there in terms of standard deviations. That just helps you kind of build the drawing of conceptually what's going on. So what are my numbers? Just give me from left to right. On the furthest left side. This would be at the bottom of your picture here. Just easier to type it than to write it.
Well, on the left side, would it be 71.7? 67.
Yeah, I want to go start from the left. Just read left to right.
Oh,
You're kind of starting from the center and going left, but just start all the way from the left and go all the way to the right. That's not how you work it out, but I just read it to me that way. So the first number is?
the first number was 76.2.
Okay, we'll do it your way. Start in the center.
That's the center.
Okay, then 80.70.
80.7.
85.2.
Okay.
89.7.
All right.
Okay, then 71.7. 67.2. 62.7.
You guys feel good about that? You agree with that? Roderick, Leah, Emily? I can't see you if you're nodding.
Sure.
Down with that.
Good. All right. So the question is less than 70 years. So I'm drawing my line here, and I want what's on this side. So now let's walk through the 3 steps again. Z-score, then change it to a probability, then make a sentence out of it.
Do you add both of them together?
Both what together?
67.2 and 62.7?
No. Z-score is value minus mean divided by the standard deviation. So we just need to get those 3 numbers in place. And I recommend you start with the mean and the standard deviation because those should be easy to spot because you use them to build this chart. And then the third number is the other number.
So the mean would be 76.2
Right.
and the standard deviation would be 4.5, was it?
Yep. And so what's the only other number in this problem?
70.
70.
So that's the third number that goes right here. Okay.
So the probability would be
Is it
point-
0? Mhm.
So
Oh, you have 1.4, never mind. Okay, so it'd be 0.0808.
negative 1.4 is the closest number that I can use. Negative 1.3 is farther away, so I'm going to use negative 1.4. And this 0.0808 is my probability, which I turn into about 8%. And is that going to be my answer?
You have to write into a sentence.
Right, but am I done with 8% or do I need to take 100 minus 8%?
Yeah, you have to subtract 100 minus 8%.
Actually, I don't think that you do because you want the minority.
You want that little part at the left side. There's 2 parts. There's 92% over here. And there's the red part, which is 8%. And I'm hoping that you can tell that between those 2 numbers, the little part over here would match up with the 8%. So that's what we want. Why do we want the little part here? What was it about the sentence that meant
Less than.
That's right, less than. So I wanted less than 70 years. I'm going with 8%. Okay. So that kind of covers everything you need to be able to do mathematically for that section.